So here one example is given to you, the cylindrical gate. The cylindrical gate, the length is here, the cylindrical diameter of the cylinder. Total diameter of the cylinder is given to you. That's the diameter. So diameter is given to you 4 meters. The length of the cylinder is given here 2 meter length, 2 meter long. Both sides there is one, but different. So what is the horizontal forces acting over it? So from this side, so this surface, if you project, so first horizontal force is easy to getting it. The first horizontal force what is acting over it. So because of this curved surface, if you project, it will comes in this way. Horizontally, if you project it. So now it's a vertical stance. So diameter is given 4 meters. So force is acting from this side in this way. So FH1, let you say, because of the fluid, it is in this way. Horizontal force is activated. That is FH1. And here from that side, FH2 is activated. So you have to finding out FH1 and FH2. So FH2 is up to only this. Projected area is only this much. This is the projected area from this side. If you consider from right hand side, if you consider from the left hand side, this total is the surface. So FH1 is equal to rho G into HC is equal to H by 2. So 4 by 2. H by 2 into this area. Projected area. Consider the projected area. FH. So rho is the 1000 is equal to 9.81. H by 2 is equal to 2. And projected area is equal to total 4 into other side perpendicular to the plane with this, let you take unitary. So 4 into 1. That is the total. You can take the G is equal to 10 also for the easier of the calculation. Instead of the 9.81, you can write it 10 for easy calculation. So 10 into 2 into 4. So 80 Newton. 80 kilonewton is acting in this side. Similarly, FH2 in this side, rho G HC. So here also rho is 1010. HC height from here there is a 2 meter. So HC from the free surface depth is the 2 by 2, so 1 meter. And AP is equal to 2 into 1. That's only. If you project only this curve, only this portion is supported by the water. So here, 20 kilometers, opposite direction. So the net force here, net horizontal force is acting FH1 minus FH2. 60. Now the force is acting, the vertical force, we have to search for it. So for this curve vertical force, already we are talking about it. This area. This area you have to consider. Because just previous we are telling the same manner. So the vertical force here in FV1, we are talking about FV1 here acting, and it is upward. FV1. Here, this. That is a FV2. That is also vertically upwards. Because net force is acting upward side. It looks like that the displaced by the cylindrical gate. Cylindrical gate displaced amount of the water that because of the weight of the water, it is some vertical force is acting over the cylinder. That's why the net force is upward in the direction. So FV1 is a semicircle area. So actually V rho G. V is the semicircle portion. So pi into semicircular area. So pi by 4. Actually, in terms of the radius, you can write it down. So if the 4 is the diameter, radius is the pi 2 square divided by 2. Into width is given as the width or length, long is given, longitudinal, into 2. Into 1000. So here you are getting this value. So 40 pi. 40 pi kilonewton. Exactly. FV1. What about the FV2? FV2 is you are getting this area, this volume. From here to here. This volume. So pi the square by 4 into 2,000. So that will comes nearly 20 pi. That is also upwards. So net vertical force is acting. This is upwards and another one is also upwards. So 60 pi of kilonewton. 60 pi of that will comes. And the magnitude of the force, magnitude and direction they're asking. So total magnitude of the force is equal to F is equal to total magnitude. Writing it, sorry. F is equal to root over of Fh square plus Fv square. So 60 into 1 plus pi square. The magnitude of this force. And the direction tan theta is equal to Fv by Fh. So theta is equal to tan inverse pi. We gives you the result here, how much values. So this way we will solve the problem. That is the way to solve this kind of the problem. There are several kinds of the problem is coming. It's not a semicircular gate or cylindrical gate. It's given directly on parabolic shape of the gate. So here it's given as a parabolic. So you have to actually, the vertical force only they are asking. Horizontal force is very easy because the same curve, if you horizontally projected, it will be looks like in this way. Vertical plate, plane surface in vertical direction. The plane surface is vertical direction. If they ask about the horizontal force per unit length, on IS question they're asking, what is the horizontal force? So this is the plane now. So how the plane is looks like? The plane is looks like in this way. If you see the perpendicular to the plane, it's the just a rectangular inside. Here is the center. So horizontal force is very easy for this question. Rho G HC into A. Rho is equal to 1000, G 9.81, HC is a 20, so 20 by 2, 20 by 2, 10 into area, 20 into per unit length is given, so 20 into. So this is 20, this is 1, so 20 into. So 10 into 20 into 9.81. That is the total horizontal force will be acting over it. So 9.81 into 2 into 1, 2, 10 to 5. So 1.962 into 10 to the power 6 Newton. The answer for this question. But in this question, if they're asking about the vertical force, how to finding out, then it will become a slight more difficult, because vertical force, that means from the curved surface, if you just from the curved surface, if you give it A and B, A dash B dash, sorry, here already A we have taken projected surface. So from the A, if you draw a perpendicular line up to the free surface, and from the B already in the free surface, so no need. So this total volume you have to find out. This total volume. This volume of the liquid, what are the weights of the liquid that is supported by the air. And net force is, net vertical force will be act downward to the surface. Again, for the vertical force, we have to do this calculation in a different manner, because in this surface, the total, this amount of the liquid is supported by the curve. This weight of the liquid is supported by the curve from the free surface. So we have to search the weight of the liquid. How much liquid is there? We have to search for it. So for this kind of a problem, if you want to get it, you have the given the formula y is equal to x squared by 4. So you have to choose some coordinate in this case, like this one. The x-axis, y-axis. So at x is equal to 0, y is equal to 0. So here, origin. At y is equal to 20, x is equal to root 4 into 20, so root 8. So nearly 9. Root over 81 is the 9. So x is equal to 8.99, some values. So that's why you are getting this coordinate. This point coordinate, you will be getting it. Next the task is you have to choose one elemental area to just integration, nothing but the mathematics in here. You have to choose one in this one. So at a distance y, along y direction is y. So at a distance of y from the surface, if you take at a y distance, if you take one small elemental area dy, where that is the x. So that's why just integration you have to follow. X dy is the area. So then total area will comes out from this. So total area will comes out. So net volume will comes out here. Total area into unit. Unit length is given. The opposite perpendicular to the plane is unit. So where y is varied from 0 to 20. So x, if you are putting it here from this equation, x square is equal to 4y. So x is equal to 2 root y. So 0 to 20, root, just nothing but here, root y, 2 will come outside. So that is the volume we will get. 2 x half plus 1 plus y to the power 3 by 2, 3 by 2, so 4 by 3. 4 by 3 in the limit 0 to 20. So total volume will you are getting it 4 by 3 into 20 to the power 3 by 2. So this way you are getting some values, volume and vertical force. Vertical force is rho g is rho g into volume. Whatever the volume you are getting into rho g you add, you'll get the particle force, which will be upward force. So this kind of the parabolic word set they have given, you have to go by integration in this. In the circle, you already know the values, that's why the same. Nothing is required. This one more question in asking in the GATE examination. Here, GATE 2016 it is given us. So this is the semicircular one cork is given here. Rectangular hole over this. So here is given R in the semicircle. It's like it. Semicircle. So semicircle, this length is already given here, L, 2R into L. So diameter is the 2R. Diameter of this 2R. So this is like this. L is the perpendicular to the plane, so we are not taking it. Here, the fluid is in this surface. The free surface is set. It's better to draw the once more time. The semicircle is supported by this fluid in this. So this side fluid is there in this way, and this side fluid is there. So these two fluids are supported. So because of this fluid, the net vertical downward force is acting over the here. Net vertical force is acting over it. To overcome this vertical force, we are giving one force F to make it in equilibrium. To hold the plug, that is a plug, semicircular plug. To hold the plug, we are giving extra. So whatever the FV is acting, the same amount of force we have to give from the downward side. Then it will be under equilibrium and we can hold the plug in its position. So F should be equal to the FV. That is the condition. So what is the FV? FV here, this is the total rectangular area minus this area, semicircle area. So total rectangle area is the 2R into L. And semicircle area, pi R square by here, this is the 2R, this length is 2R, and this height is R, here. So 2R square into L. Because this is the rectangle, first you consider, you have to got this remaining portion. So remaining portion weight. So this is the R, this is the 2R. So 2R square. 2R square into L is the volume. Here, pi by R square by 2 into L. Semicircle. This is the volume into rho into G. So this will gives you here part pi R square is a semicircle into 2. We are getting it. So 2 if you take out, so R square is common, L is common. So from rho G R square L is taken out. Rho G is already taken out. R square L also you are taking it into 2 also. So if you take the 2, so 1 minus 5F. That would be your net vertical force is acting downwards. To hold this force, we have to give the same force from the downward side. So naturally your answer will come in getting the force. Total rectangular area minus semicircular area. That is the amount of the liquid. The weight of the liquid we have to find it. That is only, this amount of the liquid is only supported by the plug. So this is the consideration here. Before coming to the buoyancy, I just telling one more thing here. That is, this is another problem and will come later. So before coming to the buoyancy, I'll just tell you the last portion here in this problem. This page. If this is not a free surface, here all cases we are thinking is a sign of the free surface. But if it is not a free surface, then what will happen? So a curved surface, just like a container. Take one curved surface is there, this like this. In a container. Over the container, there is fluid is there. And the pressure of the fluid is P1. It is not atmospheric pressure. P1 is not equal to atmospheric pressure. P1 is more than atmospheric pressure, rather. So because of the P1, some head will be developed. So in this case, if you are going to finding out the vertical force, in such a case, if you're going to finding out the vertical force, so you have to go for the free surface. So H will gives you P1 by rho. P1 is not equal to P1. Actually, it's a gauge pressure. Better to say P1 is a gauge pressure than atmospheric. Gauge pressure means this P1 is more than the atmosphere. That is P1. 1 bar gauge pressure. If you convert this gauge pressure, you will get the height. So P1 by rho g is equal to H. Here, H means from this surface above H, you have to consider one imaginary surface. This is the imaginary surface you have to consider. This is the imaginary surface. You have to consider. And if you consider there some liquid is there, this much of liquid is displaced here. This amount of the liquid. And the weight will comes. This much of liquid is displaced here. And the weight will come in this. So that is another logic here. If the pressure, if the free surface is not defined, some problem, you have to go for the imaginary free surface. If free surface is not defined, you have to go for the imaginary free surface. And that will comes from this formula. H is equal to P1 by rho g. So that much of head you have to generate. And above the head, if you go above this height, you will get the atmospheric pressure. That is, you consider as a free surface. So here, it is imaginarily concept here that this much of fluid column is supported by, is displaced by this curved surface. Hence here, the force, net force will be acting upward side. So, but this weight you have to consider. This weight you have to consider. So that is the logic in this kind of the problem. One more problem is the last problem. Just you can check it here. One vertical sluice gate is given. So gate width is given 2.5 meter. 500 kg mass is held in its position to hold the horizontal force of the one side. There is a water is there, and there is some horizontal force acting. So you are asked to finding out. So water level suddenly drops down to 2 meters above the bottom. Whether the water level drops, horizontal force amount also drops because it is depends on the height of the liquid. So in that case, the gate started sliding down. Such a situation, the gate is starting sliding down. How it is looks like, there is a, that you consider one vertical sluice gate is there. It's having some mass. So mass is acting downwards. At a take mass is acting downwards. So 500 into G. Weight is acting downwards. So to hold the gate, something is there in the upward direction. Some force is there in upward direction. And what is that force? It's a vertical plane surface problem. So as it is a plane surface problem, no vertical force will be acted on it. All force is horizontal force. So here horizontal force is acting. The horizontal force. And it's like that a normal force. So normal force into mu, coefficient of the friction, will gives you the upward direction, friction force. That is the friction force. So which is holding the weight? That is the friction force. So friction force is only here to hold the weight. So suddenly if 2 meter drops down, the level 2 meters drops down, so it starts sliding. Previously it was hold condition. But whenever it is above the, suddenly this value is getting the F value because suddenly FH reduce. In this kind of the problem, suddenly FH got reduced. As FH reduced, mu is the same. So mu into FH also reduce. Then the gate started sliding. Slides. Here you have to consider how much force changes is occurring here. So previously it was holding. After that, it is no more holding. The critical situation here, the critical situation, FH is equal to M into G. So 500 into 9.8. So mu. Only one-sided force is there. An associated friction force, already mentioned in the problem. That's why. And friction force is coming from the normal force, and normal force is nothing but the horizontal force. So when the level drops down 2 meters above the bottom, the gate started sliding. So 2 meters drops down. So FH, you have to search for it. FH is equal to rho G HC into A. Rho G HC into A. So previously some level was there. That time it was holding. Suddenly it is at 2 meters. It comes 2 meters. So from the bottom of the gate to this side is 2 meters. This side is 2 meters. So HC rho G is 1000 into 9.81 into 2 by 2 into 2 into 2. 1000 into 9.81, 5. So mu into 1000 into 9.81. 9.81 will be vanished here. Will gone, and this portion will be. So 2.5 is the width, and 2 height is coming down 500. Hence, you will get this view values. That is the way to get this kind of the problem. So might be the answer is coming A, 0.20 in this problem. So this is the way to finding out. Because of the concept is here, the horizontal force is act as a normal force. Because of the horizontal force, the friction force is upwards. It is trying to hold the plate. This force is trying to hold this plate. So that's why. Next, we'll see the buoyancy force and the pressure measurement is the remaining for the fluid statics.